open a new canvas. Okay, so we will open a new canvas now. We will save it as EJ, right? This is now the procedural justice. And we know from our data set that procedural justice has 5 items. Okay, so I'm going to go to my AMOS and I'm going to say, okay, I need 1, 2, 3, 4, and 5. Right? I'm going to rotate it, right? And this becomes my PJ diagram. Okay, so I'm going to now read the data. So I will load the data file, data SEM. This is okay, this is done. Now, once I have read the data, I will have the variable names. So I will drag and drop so it is PJ1, PJ2, PJ3, PJ4, and PJ. These are my 5 items. I will name this construct as procedural justice. Okay. What is left now is to name the error terms, right? Now I will not use the plugin now here. Why? Because if you remember, we have already used E1, E2, E3, E4, E5 in leadership. So if I ask the software, okay, and I say name unobserved variables, it will again name all of these as E1, E2, E3, E4, E5. So there will be a conflict when we will be doing the overall measurement model, when we will have lead also with us, we'll have PJ also, we'll have CB also, and when we will then be estimating, we will have multiple errors having the same names. Therefore, in order to avoid that problem that we may face later, we will actually be naming it ourselves. Okay, so we will name these variables as E14. Then we will go to the next one. We'll name it as E15. Then we will go to the next error term. We will name it as E16. Then we will name the next one as E17 and the last one as E18. Okay, so now I have labeled my error terms also. Okay, I have, and now I can use one plugin which is useful, which says Resize observed variables. So this plugin will help my model look better. Okay, so I will just make it look a little better now. Right, so this is my procedural justice model. Okay, so we will go to the analysis properties, standardized estimates, modification indices. Okay, we'll report it, test for normality and outliers. Everything else is okay. We don't need to change anything here. And then we will calculate our estimates. Now your model fit is ready. Okay, we can check our assessment for normality. So the skew is small, but there is critical ratios. They are all showing, okay, that there may be problems, kurtosis also. These are anyways ordinal data. So we were talking about in our earlier discussion also, normality assumptions are violated. Even the multivariate normality is showing very high values uh, uh, greater than 2.5 also here. So it is actually showing us a poor normality. Okay. In this case, we see that the Mahalanobis distance 287th is 43, then you have 36, then 32, and then 30. So maybe we can look at the first case, okay, which shows a little outlier, but it is not very large. It is not very large, okay, very large deviation. So it is your choice whether you would want to drop this data or you can retain. I would say it is not very large that we want to drop it. So we'll just go ahead with this analysis. Notes for the model, we have seen already the number of parameters to be computed is 10, 5 error variances, 4 factor loadings, and 1 latent factor variance, right? So it is 10 parameters, number of distinct sample moments, k plus 1 by 2. So 5 into 6 divided by 2, it is 15. And degrees of freedom is 5. Estimates are fine. Okay, they are significant and the loadings are good. Model fit. Well, we have a very poor chi-square here, 101 for 5 degrees of freedom. And the chi-square by DF is 20.2. GFI is 0.93, it is less than 0.95. Similarly, CFI is also less than 0.95. RMSE is much greater than 0.05 or 0.07. So the model fit is actually not very good. So we want to go and look at our modification indices. The modification indices tells us that, well, if you covary E17 and E16, you get a 36 drop in chi-square by 36. And if you covary E18 and E17, you get a drop of 52. So this is the path that we would actually be working on when we would be in order to improve the model. So we go ahead and we will now go ahead and start modifying our model to improve the fit.